Okay, hello guys. Today we will talk about the chapter 8 risk and return, right? As you all know, investors like returns but do not like risk. But still they invest in risky assets only if those assets, risky assets, offer them a high expected return, right? So please keep in your mind all business uh, or all assets are expected to produce cash flow, right? And the risk is the risk of that or the riskiness of this cash flow, right? If the cash flow is riskier, then your asset is riskier. Uh, Assets can be categorized as financial assets or real assets. As an example, bonds, stocks, those are the financial assets. So, can you give me an example of a real assets? Money is not an asset, is not a real asset. Intellectual property, goodwill, intangible assets. No, give me a real assets. Yes, equipment, right. Like trucks, machinery, building, exactly, real estate, or a whole business itself. These are the real assets and the financial assets, stocks, bonds. In this chapter, we will focus on the financial assets, specifically stocks, right? Stocks risk can be considered in two ways. Uh, it can be either single stock risk or we can consider in a portfolio content, right? Of course, there's important differences between the single stock risk and a portfolio risk. Uh, Single stock risk may be risky. I mean, the single stock itself may be risky assets, but if you hold in a large portfolio, then it will decrease your whole risk. We will talk about it. Yeah, I will. Don't worry about the slides. Just keep in your mind for these parts. We will continue. Don't worry. Uh, in a portfolio content, the single stock risk uh, can be divided into two components. One is the diversifiable risk. The other one is the market risk. Diversifiable risk, you can diversify by buying more stocks in your portfolio. And the other one is the market risk. You cannot diversify, you cannot eliminate, like coronavirus risk. You cannot eliminate this risk, right? Of course, risky assets offers high expected return to attract the investors, right? Right. So, in case, okay, these are the things you need to keep in your minds, right? Now, next slides, Nurlan. Uh, Today, basically, we will talk about the risk of assets and risk return trade off. We will talk about it, these two parts. Then, the other part, standalone risk, risk in portfolio. We'll talk about a little bit risk in portfolio today as well. And the remaining parts, risk and return, CAPM, SLM, these will be next lectures topics. Right. Okay. Of course, the investment's actual return will differ from the expected return, right? Uh, so how can we calculate the risk of any assets? Any idea? So how can we measure the risk of assets? R means expected return. Susan? Market rate. We are talking about the stocks. We have two stocks, assume, right? So which one is riskier? How do we know? How do we know that? How can we measure the risk level of these two assets, these two stocks? Stock X, stock Y. Company performance, rating, overall volatility expectation, maybe time to maturity. But these are stocks. We don't have time to maturity. We are talking about the stocks, Gartal. Well, basically, we can measure from your statistical courses. You may remember, we can measure the risk by calculating the standard deviation. Exactly, Aydın, standard deviation, right? Standard deviation of the historical return, of course. So it gives an idea about the risk level, right? Okay. So as you all know, this is not a statistical course; it's a finance course. But I do not want to spend much time on statistics. But still, we will talk about these basic statistical concepts. I'm sorry for this slide. I don't know why it's like this, but still you can read it, hopefully. So these statistical concepts, the probability distribution, expected rate of return, R hat, historical rate of return, right, R bar, standard deviation, sigma, and the coefficient of variation, right? So we will talk about these concepts. Okay. Okay. Assume that we have two firms, firm X and firm Y, right? And let me write the expected return here. Firm Y, we have, let's say, 20% chance of getting 100% return, right? Then we have, let's say, 50% chance of getting 15% return, and for the remaining 25% chance, let's say we will get minus 70, right? These are the firm-wise expected return with the expected probabilities, right? And we have another firm, firm X, okay? And here we have 25% chance of getting 35% return, 50% of chance getting 15% return, right? And for the remaining 25% of chance getting minus 5% return, right? So these are the expected return for firm X and firm Y. If you calculate the average, so what's the expected rate of return for both companies? How do you calculate the expected rate of return? I'm waiting for your calculation. Let's wait for a few seconds. No, it's not a Kaplan formula. Just you know the percentage, the probability, 25%, 50%, 25%. Exactly. Exactly, I mean. Yes, right. Is it 16.6? No, I don't think so. It should be 15, right. So, right. Here is the calculation. So when you multiply with 25% with 100 plus 50% with 15, I'm talking about the firm Y, plus 25% multiplied with minus 17, on average, you will have a 15% return, right? So when you calculate the firm X, you will end up with the 15% expected return. So both firm has the same expected rate of return, 15%. But one of them, firm Y, can be minus 70 or plus 100. So it looks more risky, isn't it? Right? Basically, first of all, let's define the probability distribution. Probability distribution shows all the possible outcomes, right? And it can be shown here as a graphically. Right. So this is probability distribution. How do we calculate the expected return? Basically, we multiplied the percentage, probability percentage, by the expected return, right? Assume we have a, here is the example, let me write here. We have 10% probability of getting minus 27% return, right? And 20% probability of getting minus 7 return, 7% of course. 40% probability of getting 15%, right? 20% probability of getting 30% return, and lastly 10% of probability to have 45% of return, right? Assume that these are our probabilities and these are the expected returns, right? So in this case, what is the expected return of these assets? Here is the calculation, 12.4%, right? Basically, we multiply the all probability with the expected return. Okay. Any questions up to now? Okay, good. I assume it's clear, right? Okay. Assume that these are our hypothetical investment alternatives. So these are the probabilities, right? Here, 10%, 20%, 40%, 20%, and 10%, like I did before, previous slide. One investment alternative is T-bills, so these are all 5.5%. Even in all cases, the government pays you 5.5%, offers you. So this is the first investment alternatives. The other one is the high-tech company with these returns, with these probabilities, of course. Company X, company Y, and our market index, right? So could you please calculate the expected return for each investment alternatives? Please spend a few minutes to calculate. We already did the high tech, right? In the previous slides, it's 12.4. But for all, yes, please. for company X, for all possible probabilities, for company X, expected return. What's the expected return for company X, Y, and market index? T-bill is 5.5. There is no need to calculate it. It's clear. High tech, we already did it, 12.4. But for the remaining company X, Y, and market index, could you please calculate it? Have you calculated? Do you need time? Exactly 1% for the company X. You're right. Company Y, no, it should be different for company Y. If I'm not mistaken, it should be 9.8%. Yes, 9.8% for the company Y. Probably the calculation mistake. And for the market index, 10.5. Right. You did it. Thank you very much, guys. So, based on this expected returns, right? Here is the expected returns. So high-tech company has the highest expected return, right? 12.4. And it looks like the best investment alternatives, isn't it? But what about the risk? Okay, let's calculate the risk of each investment alternatives. Once again, how can we calculate the risk? By calculating standard deviation, right? Standard deviation is the measure of how spread out the numbers are, right? Its symbol is Greek letter sigma. The formula is easy. It's the square root of variance, standard deviation. Then what's variance? How do we calculate the variance? First, to calculate the variance, first we need to find the average of the numbers, right? Which is mean. Okay. Then we subtract the mean of each alternatives and take the square differences, take the square and multiply by the probability, right? So why do we use standard deviation? Why do we need standard deviation? Any idea? To calculate the risk, yes, but basically standard deviation, yes, Nurlan, all right. Standard deviation, we have the standard way of knowing what is normal, right? So by calculating standard deviation, then we can understand, we can calculate what is normal, then what's risky. Okay. Please, okay, let's go back to the previous slide. Okay, please calculate the standard deviation of each investment, right? So I'll tell you the expected return for each investment alternatives. You know, we already did. Let me write here. 12.4% for the high tech, 1% for the company X, 9.8% for the company Y, and for the market index, it's 10.5%. Right? So these are the expected returns. So please calculate the standard deviation for each investment. Okay, then please copy these numbers, right? Then I'll show you the formula. Right? Let me wait for a few seconds to copy these numbers. Done. Good. Here is the formula. Right. Yes, this one. So we already calculate R hat, right? So R minus R hat, I did it for the T-bills, 5.5%. So it's all 5.5. So the risk, the standard deviation, the risk is 0 here in the risk-free rates. Basically, return minus the average, take the square, times probability, add them all, and take the square root, right? Please spend a few minutes to calculate it. Here is the solution. You see, we have the solution here. But anyway, try to do it by yourself, please. Okay, I'll show you my calculation for the high-tech companies. You see my calculation here. Right. Minus 27% minus the average we already calculated, 12.4%. Take the square times probability plus second minus 7% minus 12.4% square, right? You cannot see. We can see, right? 20% should be 20%. I'm not sure about the 20.64. Right. Well, this is just, well, you can calculate by yourself, right? If I'm not mistaken, it should be 20%. Right? You can do it. You can check for the others as well. Right. Okay, let's move on. Then let's compare this standard deviation in the next slide. You see the high-tech company, the average the rate of return, let's say 12.4%, right here. For company Y, it's 9.8%, and the T-bill is 5.5%. Here is the probabilities, right? So we need to compare this standard deviation. Right? Of course, the larger the sigma standard deviation, the larger the risk, right? So it means that if the standard deviation is larger, so it's the lower the probability of return will be close to expected return. Okay. So when we write all the expected return and the standard deviation, let me go back to the slides. Okay, Nurlan. Here is the basically it's the expected return, not the standard deviation, but here we have the expected return, right? So the expected return in all probabilities. So this is not a graph of comparing standard deviation. My calculation, of course, give me a few seconds, right? Yes, you see, Sandra, is it okay? Okay, right. Yes, we have the expected returns, right? Now we add this risk standard deviation as well, Nurlan, right? In that graph, we have expected returns only. Then we add this risk as well. So we know that the expected return of high-tech is 12.4%, right? We already calculate the standard deviation 20%, right? Company Y is 9.8% with the standard deviation of 18.8% and the market, right? So these are the investment alternatives. If you do not want to take risk, of course, the T-bill is the only alternatives. There isn't any risk, zero risk, right? But the return is 5.5%, low return. So forget about the T-bills. You want to take risk, assume. So out of these 4 companies, high-tech, company X, company Y, and market, do you want to invest in company X? Obviously no, because the expected return is 1% with a 13.2% risk. So that's why it's out of options. So what about company Y? Do you want to invest in company Y? Again, no, because the market itself offers you a high return, 10.5, with a low risk, 15.2, right? So it's not an option. So company Y is not company X, and company Y itself, these 2 stocks are not an option, right? So we can invest in high-tech company, which is high return with high risk, right? So this might be the alternatives. And the other alternative is the investing in the index market itself, right? Slightly lower risk with a slightly lower return, right? or no risk, no return. I mean, of course, you have 5.5% return, but I mean, it's risk-free rate. So we have three alternatives, right? Okay, which one is the best to invest? Market index or high tech or T-bill? Let's see. Let's see which one is the best alternative. To understand which one is the best, we need to calculate the coefficient of variation, right? Coefficient of variation is basically standard deviation divided by the expected return. It shows the risk per unit of return, right? Your 1% return offers how much risk? Okay. Any questions up to now? Okay, good. Nurlan, coefficient of variation is basically, here is the formula, standard deviation divided by the expected return. It shows the risk per unit of return, right? So you can calculate, you can understand your return, I mean, your risk and return altogether using this coefficient of variation. I will come to this slides, but when you calculate the coefficient of variation for each alternatives, we know the standard deviation for each alternatives. We know the expected return for each alternative. So then we can calculate the coefficient of variation, right? Basically, we divide standard deviation to return, expected return. So high-tech company, closer, yes, right. High-tech company offers you 1.6, right? Markets offer you 1.4, right? We choose the, of course, the lowest one. It means that risk per unit of return is low, right? As Sander said, we choose the market. I mean, market offer you, yes, it offers you less return, but with less risk. Then per unit of risk is the optimal in this one. Okay. So let me go back to this slide. So as you have seen, we have two identical probability of loss, A and B, company A and company B, and company B offers you high rate of return than company A, right? On expected, I mean, on average. So of course, you will prefer, in this case, you prefer to invest in high return, the B one, right? Okay. We have two definitions here in the slides. One is the risk aversion. Basically, is here is the definition, and the other one is the risk premium. Basically, the risk premium is the difference between the return on risky asset and risk-free asset. Here is the definition, right? Okay, so up to now, we calculate the expected return of single stock. We calculate the standard deviation, the risk level of a single stock, right? we calculate the coefficient of variation of a single stock, and we know all of them up to now, right? Now we will check it in the portfolio content. Assume we have $15,000 additional money to invest, and we are investing in high-tech company and the company X, right? 50%, we are investing in 50% of our portfolio with the high-tech, and for the remaining 50%, we'll invest in company X, right? So in this case, what's the expected return? High-tech company offers you 12.4%, and the company X offers you 1%. So what's the expected return of your portfolio? I'll show you. Then your expected return of your portfolio is basically the weighted average. 50% should come from the 12.4, and the other 50% should come from the 1%. So on average, your portfolio return should be equal to 6.7%, right? So this is the expected return of your portfolio. Is it clear? Any questions up to now? This is the easiest for the portfolio. Clear. But standard deviation is slightly different. Standard deviation is not the weighted average of these two individual stocks standard deviation, right? We need to calculate in a portfolio content, right? Remember, let's go back to the standard deviation of these two us. Right. Standard deviation of the high-tech company is the 20, right here. And the standard deviation of the stock X is 13.2. So what's the average? 16.1, is it? 16.6, right? 16.1, but 16.6. I'm sorry, you're right. So the standard deviation of this portfolio is, well, when we calculate the average, is 16.6. Actually, it's not. Let's calculate and let's see in portfolio content. Right. So we know that if we invest 50% of high-tech company and 50% of X company, in the recession time, our portfolio return will be 0, isn't it? Basically, 50% of these two. Below average, right? So below average, we'll take the 50% of minus and 50% of 13. Our portfolio return will be 3, right? So we can calculate the other portfolio returns as well. Then calculate your portfolio return, right? Your portfolio return for your expected. First of all, you need to calculate the expected return. Then, based on this number, calculated your standard deviation, right? So 0 is the first. Let me go back. The first in recession case return, right? 0 minus 6.7, we already calculate the average, take the square, plus with the 20% below average, it was 3 minus 6.7. So when you calculate your standard deviation, you see your standard deviation of your portfolio is 3.4, much lower than single stock portfolio stock X iTech company, right? And the coefficient of variation of your portfolio is 0.51. It's much lower than the individual investments. Okay. Therefore, diversification, with the diversification, you can decrease your risk. Okay. In the portfolio content, Susan, first thing you should do is calculate your, calculate your portfolio return, right? The first thing you need to do is calculate it. We know that 50% of your portfolio is high tech and 50% is company X, right? Then based on this 50% and 50%, calculate the portfolio return for each cases, for each probability, right? 10% here, 20%, 40%, we will have 7.5 return, right? And based on this return, we can calculate the expected return of this portfolio, P hat portfolio, right? Then assume that this is one single number, one single assets, a portfolio. Then calculate the, yes, the expected return is the average, but you can calculate, I mean, in both ways. The average is the same as well. The average is the easiest way, but you can do it with this percentage, with this probability as well, Nurlan. So when you calculate it, do you know how to calculate the standard deviation for a single stock, Susan? You know it? Yes. Then do the same thing with the portfolio return. Everything is the same, but first you need to calculate the portfolio return. Okay. Right. Yes, you're right, Algun. So the coefficient of variation, right, CV, is the lowest one here. Right. So when you calculate your portfolio, your risk, your standard deviation is 3.4%, not the average of 16.6, right? And the coefficient of variation, of course, lower than any single investment alternatives. Right? Our return is the weighted average of these two components, these two investment alternatives, but our risk is much lower, right? So that's why diversification decrease your risk. Okay. Okay, right. Why do we have a, let me go back. Why do we have a lower risk in this portfolio? how it happens. Any idea? Well, yes, because of diversification, but let's assume that, okay, let me show you. Okay, assume that we have two stocks, right? Stock M and stock M prime, two different stocks, right? But they are perfectly positively correlated. Returns is -10 or -10, right, in the recession case, or +25 and +25, and both has the same return in the boom cases, right? Then if we diversify our portfolio with these two M and M, what happened to your return? Does it change? Of course not. So diversification is not the correct answer in this case, because they are the same. Basically, they are moving together. So diversification is not, I mean, putting a new stock is not a diversification. I'll tell you, because we have a negative correlation between company X and high tech. Let me go back and show you. Right? You see, the company X has a positive return and high tech has a negative return, right? So they have a negative correlation. You see, negative, positive, positive, zero, positive, negative return, positive return, negative return. Because of this, let me go back to negative correlation between these two stocks, our portfolio have a lower risk. Okay, is it clear? Any question, guys? Thank you, Amin. Any others? If you have any questions, please ask. Any part that you don't understand, please ask right now. Okay, let's start with Alida. When will a portfolio increase risk? Well, if both has the same correlation, perfectly correlated stocks in your portfolio, then it will not increase the risk, but nothing happen, right? So anything less than one coefficient correlation between two stocks decrease your risk in your portfolio. If a stocks were positively correlated, the risk would be high. No, if it is perfectly one, I mean, if it is perfectly correlated, which is the correlation coefficient is 1, then nothing happen. Anything less than 1, even it's a positive, let's say 0.5, will decrease your risk, right? In case if they were moving positively but with a different rate, still again almost the same question with Nurlan Ergun. Even if it is less than 1, 0.9 is enough to decrease your risk, right? Of course, if this is, let's say, let's say we have 0.5 correlation between two assets and the 0.9 correlations. Of course, 0.5 decrease the risk more, but still both are decreased. Portfolio generally goes lower Not all. Well, it depends on the portfolio. If you are buying the same type of assets, if they are moving together, it will not decrease your risk, of course. But if they move, in case coefficient, there is no meaning for diversification. Could you please refer to the graph of MM? Right, right. This one, right? If you are buying if two assets are perfectly positively correlated, there is no need. That doesn't mean anything else. It's not diversification. You are just buying two assets with a different name but moving together. Nothing, right? For lowering the risk, right? Like this, look, this partially correlated two assets, right? We have W and we have Y. You see their rate of return over time, the red one and the let me show this red one and this blue one, and your portfolio return is the green, right? So your portfolio return, your portfolio risk is lower than any single assets. You see? Sander, is it clear? Let me go back. Yes, green show the rate of return of the portfolio. But you see the risk is lower, right? And you can calculate the risk. We need the numbers, but anyway, from this graph, you can find the return. Risk, please. I mean, why do you mean by risk? Which one? I mean, risk, please. I couldn't get your question, Sander, once again. How can we know that? It's because, right? Okay, let's put this one, right? So we have two perfectly negatively correlated stocks. So the correlation coefficient is -1, right? If one of them is increased, the other one is decreased, right? At the same percentage, like a mirror. Okay, and both of stocks average return is 15%, right? So when you buy this 50% of 50%, 50-50 both assets, 50W, 50M, right? Here is the return plus in for the W, let's say plus 35, right? And here is the minus 10. I'm not sure about plus 30. Let me calculate it first. I'm sorry. Well, yeah. Here is the number, right? You see 40 and minus 10. So starting point, W has a 40% return, right? The other one, M, has a minus 10% return. So if you buy these both assets with 50%, 50%, your return will be 15%, isn't it? Sander, right? Next year, the blue one, M, has a return of 40, and the red one has a return of minus 10. Again, the average is 15%, right? They're perfectly negatively correlated. So your portfolio return is always 15%. Anyway, right? So you decrease your risk. You see, if a single stock, if you invest in a single stock, your return will vary between minus 10 and plus 40. But if you invest in this portfolio, your return is always 15%, like risk-free asset. You see how decrease your risk in a portfolio content? Okay, good. Guys, any questions? I'm planning to stop here for today. I will continue next week for the remaining part.